Hello and welcome back. This will be the first video on Chapter 2, which is all about functions. So the first section is going to be looking at some definitions, and we'll start with a relation. And relations are sort of informally, they describe the relationship between things. Now this is quite vague, so I just want to look at a couple of examples really quick. So for instance, one relation might be a relationship between a polygon and the number of sides that it has. So for instance, a square will have 4 sides, or a triangle will have 3 sides, and a trapezoid will have 4 sides. And when we're describing a relation, what we normally do is we write these things in pairs. The thing on the left and the thing on the thing on the left and the thing on the right will be related to one another based on some description. So here's another relation, and I've just described these as pairs. So I've said that 2 is related to 4 and 2 is related to 6. 3 is related to 6 and 3 is related to 9 as well. 4 is related to 8 and 4 is related to 12. 5 is related to 10 and 5 is related to 15. So this is just a made-up relation that's describing some sort of relationship between numbers. Some things are related to more than one thing. So 2 is related to both 4 and 6, and on the other side, 6 was related to from 3 and from 2. So there's all sorts of things that can go on, and essentially anytime that you have a set of ordered pairs, we can talk about it as a relation. So a relation is just a set of ordered pairs. You give me any list of ordered pairs like this, that forms a relation. The domain and range are what are on the left and the right halves of the ordered pairs, respectively. So, for instance, if we look at the domain of the first relation, we have 3 ordered pairs in the relation. There are 3 things on the left: squares, triangles, and trapezoids. So that would make up the domain of this relation. The range is going to be everything on the right-hand side. So 4, 3, and we already mentioned 4, so we don't have to list it again. So the range is just going to be the set containing 4 and 3. So ultimately, the domain is just everything that's on the left-hand side, and the range is everything that's on the right-hand side. Here we've got 8 ordered pairs, so we'll have to be a little bit more careful. But the domain, when we look at the left-hand side, we've got 2, 2, 3, 3, 4, 4, 5, 5. So the domain is just going to be 2, 3, 4, 5. The range is everything on the left-hand side, so 4, 6, 6, 9, 8, 12, 10, 15. So 6 was listed twice. We don't have to list it twice. In fact, we shouldn't. So our range is going to be 4, 6, 8, 9, 12, and 15. I believe I forgot one. Yeah, so 10 is also in this list. So we'll just add that to the end. Okay, so when we're describing a relation, there's a nice way to sort of visualize this as well. We can sort of draw lines that connect things that are related to one another. So over here I have my domain, and over here I have the range, and squares and trapezoids both have 4 sides, and the triangle has 3 sides. So I can start connecting these guys so that we can see what is related to what. So here, if we come back up to our original relation, I had everything is related to twice the value and to 3 times the value, just as a made-up relation. So when we come back down here, we can start drawing lines between these as well. So 2 will be related to 4, and 2 will be related to 6. 3 is related to 6, and 3 is related to 9. 4 is related to 8, and 4 is related to 12. 5 is related to 10, and 5 is related to 15. This starts to get a little bit messy once we have lots of values and lots of things being related to more than one. So 2 is related to both 4 and 6. 6 is related to both 2 and 3. So in this scenario, drawing this picture can be helpful, but sometimes it gets a little bit busy. We're going to start talking about functions, and this is probably not the way that you've seen functions before if you had them defined for you. But a function is just a particular type of relation, and it's a relation where each element of the domain corresponds to exactly one element in the range. So let's come back up here and check this out. So when we look at the domain, we're going to consider each one individually. So let's look at square first. Which values of the range does square correspond to? It only corresponds to 4. So square only corresponds to one element in the domain, in the range. Trapezoid only corresponds to 4 as well. And triangle only corresponds to 3. So this is what we'll call a function. And again, a function is where each thing in the domains, we'll have to go through each one individually and consider what is it related to. And since the square is only related to 4, it's only related to one thing. The trapezoid is only related to one thing, and the triangle is only related to one thing. That means that this is a function. Down here, this is not a function. Because we can find something in the domain that's related to more than one thing. Right here. 2 is related to both 4 and 6. In a function, if this were a function, 2 could only be related to one thing. And since it's related to 2 things at once, not a function. So let's look at some more examples. So this is just an example from the textbook. When we have that 1 is related to 2, 3 is related to 4, 5 is related to 6, and 5 is related to 8. Well, this should have caught our attention right here. 5 is related to 2 different things. 5 is related to 6, and 5 is related to 8. Not a function. We can't have something being related to 2 different things at once. Here, we've got 1 is related to 2, 3 is related to 4, 6 is related to 5, and 5 is related to 8. No element of the domain. So if we write down what the domain is everything that's on the left-hand side. So the domain is going to be 1, 3, 6, and 5. And what you'll notice is that 1 is only related to 2, 3 is only related to 4, 6 is only related to 5, and 5 is only related to 8. So this is a function. So how can we start relating functions to things that we've already seen before? Well, functions are quite often going to be expressed as equations. So when I'm relating, say, 2 numbers, I can use an equation to figure out what this will be related to. So for instance, here I have y is equal to x squared minus 2. So I'm going to essentially try to define my relation as, well, x, whatever number I want to plug in for x will be related to whatever value y pops out. So for instance, if I plug in negative 2 into here, negative 2 times negative 2 is 4, minus 2 is 2. So negative 2 will be related to 2. So we are defining this relation. Negative 1, if I plug in a negative 1 in here, I get negative 1 squared is positive 1. Positive 1 minus 2, well, that's negative 1. So negative 1 is related to itself. It's perfectly valid. Negative 1 can be related to whatever we want it to be. 0, if I plug a 0 in there, I get negative 2. So 0 is related to negative 2. 1, if I plug a 1 in there, I still get a negative 1. 1 squared minus 2. So 1 is also related to negative 1. And if I plug a 2 into here, 2 squared is 4, minus 2 is 2. So 2 is related to 2. And if we take a close look at this, this is in fact a function. The domain, as I've defined it, is going to be any number that we can plug in. And when you plug in a number in for x, we get a value for y. And moreover, we get exactly one value of y. So this is going to be a function. Now we have to be careful because not every equation will give a function. So let me go through a quick example of that. So here we've got x squared plus y squared is equal to 1. And in order to really understand this relation that I'm trying to define, or what I think will be a function, I'm going to have to plug something in for x, and I need to know what value of y I get. So if I give you an x, I need to say, or I need to know what will it be related to. So how do I do this? I'm going to solve for y. So when I do this, okay, I'm going to solve for y, so I'm going to get it by itself. I will subtract an x squared for both sides. The x squareds will cancel over there, so we'll get y squared is equal to 1 minus x squared. And I need to get y by itself. I don't care about y squared, I care about y. So here, if I write y, I'll need to take the square root of both sides, but I could get plus or minus the square root of this left-hand side. And this is where we'll see that, well, this is in fact not a function, because I could have a positive number or a negative number come out. This is not a function. So, for example, if I plug in x is equal to 2, what will happen here? I'll get y will be plus or minus the square root of 1 minus 4. 1 minus 4 is negative 3. So this is going to be plus or minus I times the square root of 3. But I have a plus or minus here. So when x is 2, I could have y is I times the square root of 3, or I could have y is going to be negative I times the square root of 3. And we can see that because we get plus or minus, 2 is related to two things. So this is not a function. I realize I wrote this wrong at the beginning. Not every equation defines a function. So this is what we should see, and here alarm bells going, because this is not going to be a function. 2 can't be related to two different things. Whereas before, it was pretty clear that when I solve for y here, if you plug in a value for x, there's only one y value that comes out. So when determining whether an equation gives a function, look to see how many solutions are there for y for an individual value of x. If you plug in an x, do you know what y is? Or could there be multiple solutions? Multiple solutions means not a function. And then the very last thing that I'll mention is that in these examples, we call x the independent variable, since we can choose whatever value we want. Our choice is independent of anything else. I could plug in a 2, I could plug in a 6, I could plug in a negative 13. It doesn't matter. It is independent of everything else. Y, on the other hand, depends on x. When you pick an x, you plug it in and you see what y value you get. That means that y depends on x, so we call it a dependent variable.